problem we have a cone diameter of base 60 mm and axis 70 mm. It says that it is cut by a sectional plane perpendicular to VP and 45 degree to HP, while the sectional plane is passing through a point 40 mm above HP. Now considering these data, let us start to solve this particular problem by drawing it. Now since the diameter of the base circle is given as 60 mm, we'll take the radius of 30 mm. You can measure it with the grid sheets counting for 3 boxes, and we can draw a circle of 30 mm radius, which will give us a 60 mm diameter circle. Since the circle does not have any reference points, it is required that we divide the circle into 8 equal parts so that we get 8 points, which will be our reference while we are projecting this circle further. Let us project these points to the front view and we'll generate the front view of the cone. The front view of the cone has a height of 70 mm that is given in the question. Name these points, reference points in the front view, and measure the height of 70 mm from the center of the circle, from XY line. We'll name the axis line as O', The axis line has to be drawn with one longer and one shorter line. The front view of a cone will look like a triangle. The preference has to be given for the axis line, not for the projection line. So all these lines are drawn with thin lines, while the dark lines will be drawn with a pen, which I'll show it to you at the end of the video. Mention the diameter and the height. The sectional plane data is given as that the sectional plane is perpendicular to VP and 45 degree to HP. So angle HP, you are supposed to draw that in VP. You can draw the sectional plane anywhere, but the condition is given that the sectional plane is cutting the axis at 40 mm height from the base. So we'll mark a point at 40 mm height and take a line which is at 45 degrees to the XY line, and that will be considered as a sectional plane. You must show the sectional plane by drawing these arrows at the end of that section line. Arrows shown downwards means that the downward part of the sectional plane will be retained and the upper part will be removed. So that there you go, the sectional plane is at 45 degree to the horizontal line. Now we need to check all the points where the sectional plane is cutting the actual solid. While the cone does not have any edges, we will consider the slant generators and the base curves. The names of the slant generators and the base curves are listed here. OA, OB and the others will be slant generators, AB, BC and others will be base curves. We will check where the sectional plane is intersecting with each of these elements. So it intersects at OA, we'll get 1 dash there. Likewise, we check for all the remaining elements what we have listed here, the slant generators and the base curves. Like we got 1 dash on OA, in the same manner, if we go on checking, we'll get the next intersection at OB, that is 2 dash. Likewise, we get all the remaining points checking the slant generators. 6 dash will be put on bracket since it is found behind 4 dash. In the same manner, 7 dash behind 3 dash and 8 dash behind 2 dash. If you check the base curves one by one, whether the sectional plane is intersecting the base curves A to B, sectional plane is in the front view, A to B plane is here, A to B is here, and there is no intersection between the two. The same manner you check the remaining base curves, none of them have the intersection with the sectional plane. So none of these base curves has a cut point. We'll project these cut points to the top view by drawing projection lines vertically to OA in top view. So from 1 dash to OA, that point will be considered as 1 in the top view. In the same manner, repeat it for the remaining points. Check this point 3 and 7 dash. When we draw a projection line to the top view, it coincides with the line OC and OG. So we will not be able to get the intersection. To get that intersection, you can draw a horizontal line and a vertical line as it is shown in the diagram. And from there, you can draw an arc from the center to the line OC and OG. So that distance will be projected, and where that arc intersects can be considered as the points 3 and 7. This 7 on the line OG. For the remaining points, we can draw the projection lines and get the intersection on the corresponding top view of those slant generators. So after marking all the cut points on the top view, we can connect these points with a smooth curve. Remember, this is a cone, so we need to connect these cut points with a smooth curve drawn with freehand sketch. And later you can darken it. In the same manner, we can darken the top view where the portion that is retained after cutting the cone. This base circle will be completely visible, and the oval shape that we have got is a cut section, that is a removed part from the top of the sectional plane, which can be hatched, which gives us a clear picture of the sectional top view what is given in the question. And here we can darken the front view of the retained part. As I mentioned, the bottom part of the sectional plane will be retained. No need to darken the slant generators except the outer part. Now to generate the true shape of the section, from the sectional plane you need to draw a parallel line at a convenient distance where it is not overlapping. Next, hold a scale on this x1 y1 line, which is a new reference line, and take a set square of 90 degrees and draw perpendicular lines from every cut point. After this, you can measure the distances of these cut points from xy line to the top view. So xy to 1 can be measured using a compass on the line where you have 1 dash. You can cut an arc. That point will be the new point 1 to get the true shape. Repeat this for the remaining points. From xy line to 2, on the 2 dash line you can cut the arc. From x1 y1 line we'll get the point 2, and next from xy to 3, cut the arc, you will get the point 3. xy to 4, from x1 y1 you cut the arc, you will get 4. Repeat the process. And we get all the 8 points from the x1 y1 line. You can join them with a freehand sketch by drawing smooth curve. First you can draw it with thin lines or thin curves, and then you can connect them with darker ones. Make sure that you are drawing smooth curve. It should not be connected with lines since it is a cone. This portion can be hatched with 45-degree lines equally spaced, and then this will be considered as the true shape of the cut section for the given problem and the conditions. That gives us the solution for the problem.